Hi everyone, welcome to the first lecture video for Psychology 230. This is our introductory course on statistics for the social and behavioral sciences. Dr. Bianchi here, and at this point you should have already reviewed the course syllabus, you should have already downloaded the course calendar, and you should have solidified your access to the MindTap platform, which is directly accessible here through D2L, where you will find your course textbook as well as various quizzes and assignments that you'll be completing online as you watch my different lecture videos in the course and as we lead up to the in-person meetings. We are moving this week into the first chapter of the course, and it's basically an introductory chapter to statistics. So right now you should be in the process of reading through chapter 1, and you should be watching my lecture video as you are now. This chapter will be broken up into 2 lecture videos, just to kind of break it up. There's a lot going on in this chapter as it's going to really set the stage for the rest of the course. So I have broken it up into 2 videos. Okay, kind of cutting the chapter in half. This is the first video for the chapter. So what we're going to be doing here is just introducing the field of statistics. Many of you, when you hear statistics, you think of numbers, facts, figures, averages, those kinds of things. And that's correct, those are statistics, but statistics really refers to a set of mathematical procedures that we use in the sciences to evaluate data. So if you've ever worked with an Excel spreadsheet, or you've ever organized your budget or collected any kind of data whatsoever, you were dealing with some type of statistical results. And statistics, this entire course, is going to introduce you to the different tools that we have available for taking all of that data and reaching some general conclusions. So these are the different kinds of techniques we use to evaluate data once it has been collected. They allow us to organize and summarize information. That way we can figure out what happened in our research study or our experiment. They allow us to easily communicate the results to others. We'll be spending some time this semester looking at graphs, tables, and other visual ways to present data. And mainly they allow us to address our questions of interest and figure out what happened in this study? What happened in this experiment? Did this drug work? Did this manipulation have an impact on behavior? Those kinds of questions that we're interested in researching. Okay, so what I want to do just to get started here is to just let everybody know that you really shouldn't have too much anxiety about the mathematical components of this course. The math in the course is relatively straightforward. If you can basically do order of operations, you should be successful with the math. I tend to emphasize much more heavily a conceptual understanding of the concepts. So the math is pretty straightforward. What is more difficult is understanding kind of the purpose of the different statistical procedures we're doing and how to interpret them. Okay, but basically if you could do addition, if you can subtract, multiply, divide, and follow the order of operations, you should be completely fine in this course. Okay, if you don't have a background in the order of operations, you definitely want to go review that. That is an assumption I have that you're capable of performing that in this course. Okay, can you calculate an average score by adding up all of the scores and then dividing by the total number of scores? Okay, that's an average score. We'll be doing a lot of that. Okay, and then basically we just kind of have, more steps on the basic math. Can you subtract? Can you add? Can you multiply? Can you take the square root of numbers? These are all different kinds of calculations we'll be completing in here. And so I'm just showing this to everybody to ease the anxiety that this course is going to be very mathematically difficult. Again, the math is relatively straightforward. I don't think most of you, especially if you have the prerequisite math backgrounds, are going to have any issues with the math, okay? The conceptual aspect of the course can be more difficult, which is why reading the textbook and watching these videos is critical if you want to get an A in the course. Another assumption a lot of students have coming into this class is that statistics is really boring and that it's a requirement they need to get out of the way. And it's my goal this semester to emphasize that statistics is actually really fascinating. It's super interesting, and it's also an extremely marketable skill. We live in a data-driven world, and many careers require that you can at least be statistically literate, if not capable of running your own statistical tests on some basic data sets. Okay, so these are very, very marketable skills. Every single day we're being bombarded with statistical information, and it's a goal of mine to give you the ability to interpret that information accurately, as well as run some of your own statistical tests on data. Okay, you might have seen in the syllabus that the course ends with a statistical analysis project where I'll be giving you a data set and you'll be running some basic statistical tests to answer some different questions. Here are some interesting results that came out of big statistical data sets. This was from Star Wars, and they asked thousands and thousands of people who they thought the most pivotal character was, who was the most important to the plot. And you can see that the bigger the dot is, the more important people, thousands of people, found that character to be. So this is just an example of cool kind of results, visual results that we can get only by using statistical procedures. Okay, here's the same thing with Twilight. Okay, most people found Edward to be the most pivotal person in that story. Okay, but you can see the other results that people were reporting as well and how popular they were based on the size of the name. Here's one for Game of Thrones. Okay, so these are just some of the cool kinds of things that we can generate through statistics. It doesn't have to all be numbers, boring, and bland. We get a lot of cool results from our ability to analyze data. This is some results that come off of a dating website known as OkCupid. Now, you might be aware of the fact that all of these websites, Facebook, OkCupid, etc., they use statistics in order to analyze their data. Okay, it's just fancy math. They use computer algorithms to kind of figure out different patterns in the data. And OkCupid studied all of their users and questions, and they found the top 4 most predictive questions for a successful relationship coming off of this website were the following listed on this screen. Okay, so if you agree with somebody on these 4 questions, you are much more likely to have a successful long-term relationship. Okay, so just kind of interesting stuff, kind of counterintuitive that maybe these questions would be the 4 most predictive, but cool results that statistics allow us to generate. So beneath this video, I have posted just this short 3-minute video overview. I really encourage you to just pause my video right now and jump to the link right below this video on D2L. It's a 3-minute overview, really emphasizing why statistics is such a cool subject and why it is one of the most marketable skills that you can add to your portfolio of skills. I think they do a great job of communicating how statistics is applicable across a wide set of majors and career fields. So please go ahead, pause this lecture video, and check out the 3-minute video underneath this entitled Why Study Statistics. Okay, so hopefully you were able to check out that video. With all of those introductory points in mind, the fact that statistics is an extremely marketable skill, it is applicable across a wide array of career fields and majors, and it really is helpful. It allows us to take huge sets of data and summarize results into some simple, straightforward conclusions. With all of that in mind, we're going to go ahead now and jump into the core of Chapter 1. The concepts in this chapter will set the stage for the rest of our course this semester. This course builds on itself as we go through each chapter. Those concepts will be coming up again and again and again. So in that sense, the course is cumulative. So this is a very, very important chapter. You definitely want to make sure you read this chapter in addition to watching these videos where I summarize major points. Okay, so we're going to be looking at some key statistical terms. We're going to be looking at some measurement and research terms that are going to be coming up over and over again. We'll talk about more specifically the place of statistics in the process of science. And at the end, we'll just make sure we're comfortable with some basic mathematical procedures that are going to be coming up as we proceed through the material this semester. Okay, so statistics simply refers to statistical procedures. And again, it's just a set of steps, mathematical steps, for organizing, summarizing, and interpreting information. Okay, statistics allows us to determine what kinds of conclusions are justified based on the results and the data that we collected. The goal of all of statistics is to provide an accurate and meaningful interpretation to the data, and it also sets up a process that's standardized, right? Everybody is using statistical procedures. There are rules about what's appropriate and what's inappropriate given the data, and basically everyone is held to the same objective platform for evaluating their data. Okay, it provides a standardized evaluation process. A really important distinction for us to make upfront in the course is the difference between populations and samples. When we talk about a population in a research context, let's just use psychology, okay, when we talk about a population, we're talking about all of the individuals that we're interested in. Okay, so for instance, if I'm interested in studying clinical depression, the population is everybody in the world who's diagnosed with clinical depression. If I'm interested in studying third graders, the population is all of the people of third grade age all over the country or all over the world. Populations are large and they are all of the people that we're interested in. A sample is a subsection of the population, a set of individuals that are recruited from the larger population because we have access to them. We're able to recruit them into our research. And the goal is that the sample represents the population. So for instance, if I am interested in clinical depression, well, maybe my sample contains 50 people from the Tucson UMC who have been diagnosed with clinical depression. Those are the people that I can access. That sample of 50 people represents the larger population of interest, the population of clinically depressed individuals. Okay, so a sample is a smaller subsection of a population. Just to give a really simple analogy, you can imagine a population being an entire cheese pizza with pepperoni on top, and a sample is just grabbing 1 or 2 slices. Okay? That's going to be a really important distinction throughout the course. Usually in the behavioral sciences, in psychology, we are typically studying samples. We don't have access to the entire population, so we need to recruit samples that are representative of the population in order to conduct our research. Okay, samples are going to allow us to test out our predictions about the larger group at hand, the population, that we don't have easy access to or that we just logistically cannot collect data on, at least not everybody in the population. Okay, this is just a visual, okay, getting across the same point. Okay, the population is all of the individuals of interest. Okay, whatever your research question is, the population is all of the people that you're really interested in. And then in research, you typically take a sample from the population. Okay, whoops, sorry, I think we had a little technical issue with the recording software. So we have our population, all of our individuals of interest, and then we have a sample selected from the population. We conduct our research on the sample, they participate in our research study, but the goal is that the results of the sample are applicable to the population, okay, that we can generalize those results to the larger group. So what I would like you to do right now is I would like you to just pause the video and see if you can come up with your own example of a research question that you are interested in. Now, it doesn't have to be in psychology. It can be in nursing, education, whatever your field is. Come up with a research question and tell me who is the population of interest, and then give me an example of a sample that you might be able to recruit here in Tucson, Arizona. Okay, take a second to do that, and I'm going to want you to bring that to our first meeting. Okay, so take a moment to pause and come up with your own example here that fits this visual diagram. Okay, so now that we have a better understanding of the difference between populations and samples, we have some more terminology to go through. The term variable refers to anything you can measure that changes over time or has different values for individuals. Okay, a variable is anything you can measure that has different results for different people. So if I measure your weight, weight is a variable. I can measure your height, that's a variable. We can give people IQ tests, their IQ score is a variable. I can measure how many ounces of water you've been drinking today, that's a variable. Anything that I can measure and categorize in some sense is a variable. What color is your car? What color is your bicycle? These are all variables. The word data is plural. It refers to multiple measurements or observations. So typically when we have a data set, we're talking about a compilation of measurements on different variables. Okay, a data set is a collection of all of those measurements. And the word datum is singular. So if I just asked one student how old they are, that student's age is a datum. Okay, typically we call that a raw score. Now, here's another key distinction that we're going to make that comes right off of the heels of populations versus samples. The word parameter refers to populations. If we are able to study the entire population, okay, we're talking about dealing with parameters. Parameters are values that describe a population. Okay, so if you had a parameter, that would mean that you collected data on the entire population. Statistics are much more common. Our course is even called statistics. Statistics are values that describe a sample. Okay, so if I was to tell you that on the first exam, the average score in the course was a 75%, that's a statistic. It's a value that describes the performance of the sample, okay, the class of psychology students taking statistics. Okay, so when we are studying populations, we're talking about parameters. Okay, and statistics are values that describe samples. Now you might be asking yourself, why are we even talking about parameters if in the social and behavioral sciences we rarely have access to populations? Why are we even focusing on this? Well, there's two things to bring up. One is that sometimes we do have access to the population. It really depends on what our research question is. Maybe I am interested in studying an anti-bullying intervention for a third grade classroom, okay? And I am working in a school and I'm solely concerned with that third grade classroom. I don't care about the results applying to other schools across the country. I just want to reduce bullying in one third grade classroom. Well, if you think about it, then my population really just is that one third grade classroom. Those are the only students I'm interested in intervening on. And so in that case, I would have access to the entire population and I would be using parameters. When I collect the data, I would be talking about parameters, okay, because I have access to all of the third graders that I'm studying in this anti-bullying intervention. The second point is that even when we use samples and we calculate statistics for the sample, remember back to this visual, we still care about the results generalizing to the population. Okay, the whole reason we use samples is to give us insight into what would happen to the entire group had they been exposed to the treatment, to the intervention, to the experimental manipulation. Okay, so we use samples to gain insight as to what would happen to the entire population in our study had we been able to study all of those people. Okay, a couple more important terms here. Okay, descriptive statistics. The first part of this course, the first couple of weeks, we're focusing on descriptive statistics. Descriptive statistics is a branch of statistics that allows us to describe our data. Whenever we collect data, let's just say we have an Excel spreadsheet and we have measured age, IQ score, GPA, you can think of any other variables, weight, height, whatever it is we're studying. Descriptive statistics allow us to describe what's going on in the data. What are the average scores? What are the range of responses? Is the data really spread out? Or is the data really clustered together? Are people responding similarly? So descriptive statistics are a set of tools that allow us to summarize, organize, and simplify our data. if you've ever seen a graph or a table of data in an article or in the media, those are descriptive techniques. Once we describe our data, we can go ahead and use inferential statistics. Inferential statistics allow us to test whether or not our research predictions are supported by the data. Okay, this is where we basically are able to test our hypothesis in our study. So we will spend the second half of the course looking at a variety of inferential statistical tests that allow us to study samples and draw conclusions about populations. Okay, these are used very often to interpret experimental data. And this is where you see terminology like the margin of error or the data is statistically significant. We can be confident that this treatment or this drug would be effective for all of the individuals diagnosed with this kind of cancer or for all individuals diagnosed with autism, etc. So descriptive and inferential statistics go hand in hand. Whenever you have data, the first step is to describe it, and the second step is to run an inferential statistical test that allows you to test out your research prediction and allows you to see whether or not the data support your research prediction. Another key idea that's going to be coming up over and over again is this notion of sampling error. A sample is never identical to the population. Okay, whenever we take a subsection of a larger group, it's not going to be identical to the population on every level. Now, hopefully it's going to be very similar, but there will be some discrepancy. So that is what we call sampling error. It's the discrepancy or the amount of error that exists between a sample statistic and the corresponding population parameter. And a great example of this is the margin of error that you see in political polls. Okay, you may have seen something like this. This poll was taken from a sample of registered voters and has a margin of error of plus or minus 4 points. What that's saying is, okay, we have recruited and studied 100 Republicans or 100 Democrats or 100 independent voters, and we've gotten their responses to the poll. And we're confident that if we really measured all Republicans, all Democrats, all independents, if we really had access to the entire population of each one of these groups, that the true result would be about 4 points above or below what we got here in this sample. Okay, there's a margin of error of about 4 points above and below what the sample has reported. Okay, that is sampling error. Here's another visual that does a good job of getting this point across. Here we have a population of 1,000 college students. Let's just pretend that we have 1,000 students here at Pima, or maybe we're looking at 1,000 students at the U of A, okay, that are enrolled in a certain program or a major. For our intents and purposes, this is the population, and here are the parameters. The average age of the population is 21.3. The average IQ is 112.5. And the sex breakdown is 65% female and 35% male. Now, if I randomly select a sample of 5 people from this population, here's my first result. Sample number 1, I've collected data on 5 people. Now look at the average age of the sample, it's 19.8. Okay, it's a little bit different than the average age of the population. Okay, close, but not identical. Here's the IQ, 104 and change. Again, that's a little bit below the population IQ. Okay, this is sampling error, these discrepancies between sample statistics and population parameters. Okay, even the sex breakdown isn't completely accurate. Here it's 60% female and 40% male. Okay, and you can see the breakdown in the population is a little bit different. The natural discrepancy that exists between population parameters and sample statistics is what we call sampling error. Now, error isn't a bad thing. It doesn't mean that something went wrong. It's a natural discrepancy. Okay, whenever you have a really, really big group of people or animals, whoever you're studying, and you take a smaller amount from that group, you're going to get some discrepancy in the statistical results. What you can see is that in both samples, okay, the results on each variable are pretty close to the population. Yes, there's discrepancy, but they're all pretty much within line. Okay, maybe the only discrepancy here is that in sample 2, we get the opposite sex breakdown where it looks like there's more males than females. Okay, but key point is that samples are always a little bit different than their populations. That's called sampling error. So here's a diagram I really want to walk through. It walks us through the whole process of research. Okay, here we have a population of college students, and the research question is whether or not reading printed pages in a textbook is more or less effective than reading digital computer screen textbooks, okay, digital electronic books. I'm not sure which one you prefer, but let's imagine that we conducted a study where we randomly selected, 15 people to a sample where they had to read a physical copy of the statistics book this semester. This means they're reading printed pages from a physical book. And we selected another 15 people to be in the computer group. Okay, they had to read the course textbook digitally online on the computer. Okay, and what we are obtaining are the test scores for students in each sample. So here are the test scores for all of the students who are reading physical printed pages, and here are the test scores for all of the students reading the digital textbook. Now, I don't know about you, but when I look at these batches of data just like this, it's really hard for me to reach any conclusion. Okay, I see a lot of similarities. The point of statistics is that it's going to allow us to determine whether there is a statistically meaningful difference between students who read from printed pages and students who read on the computer screen on their test scores. Well, step 1, we need to summarize and describe the data. That's where descriptive statistics comes in. We can plot our data in different graphs and charts. Okay, and we can even compute the average score. The average score on exams for students reading from printed pages is a 26, and the average score from students who read on the computer screen is 22. Okay, so right off the bat, you might be thinking, wow, there's a 4-point difference. Reading from the printed pages looks like it's more effective, but that is a premature conclusion. The whole point of statistics, put this in your notes, it's definitely going to be on the exam. The whole point of going through inferential statistics is that it allows us to determine whether or not this 4-point difference is meaningful, because it's possible that this 4-point difference is due to sampling error. Okay, it could just be due to the fact that the people in both of these groups are different representations of the population, that there is sampling error accounting for that 4-point difference. Okay, so to put this more formally, inferential statistics is going to allow us to interpret these results. The sample data do show a 4-point difference between these two methods of studying. However, there are two possible ways to interpret the results. One is that there is actually really no difference between the two studying methods, and that the sample difference is just due to chance. It's due to sampling error. The alternative conclusion is that there really is a difference between these two methods, and that sample data, that 4-point difference, accurately reflect the difference. Statistical tests are going to allow us to decide whether that 4-point difference is due to sampling error and thus can't really be trusted as a real effect, or whether that 4-point difference really does suggest and indicate that reading from printed pages is more effective. So a key takeaway point from this slide is that just because you have two groups and the average score is different, you can't automatically say one is definitely better than the other. You need to go through a set of statistical tests in order to show evidence that the difference between those groups is not due to sampling error, but is actually due to real systematic differences between the two groups, and in this case, the two studying methods. That's the whole point of everything we're talking about this semester. Okay, so this is a great study guide. This is showing you where statistics comes in the process of research. Okay, we start with a research question about a population. We collect data on samples. We may subject them to different conditions or different aspects of the study. And then once we collect our data, we describe it. And then we use inferential statistics to rule out between the results being due to sampling error and chance, or whether there's real systematic, important results here supporting or maybe not supporting the hypothesis. Okay, a couple of questions for you to just do at home. Okay, let's do some reinforcement here, make sure that we're understanding everything we're talking about. A researcher is interested in the effect of amount of sleep on high school student exam scores. A group of 75 high school boys agree to participate in the study. The boys are an example of what? A statistic, B, a variable, C, a parameter, or D, a sample. Okay, so we're interested here in sleep and high school student exam scores, right? Our entire population is high school students. Now, we can't access all high school students all over the world. Very difficult, very expensive, logistically almost impossible, but we can get 75 high school boys, maybe from Tucson School District. Those boys are an example of a sample. They are a subset of the population. Okay, let's do some true and false. Let's start out with the first one. Most research studies use data from samples, true or false? Okay, particularly in psychology. Most research studies use data from samples. Okay, you should be saying that that's true. We talked about how it's logistically difficult, it's very expensive and nearly impossible most of the time to access the entire population. Unless we have some really specific research question and we're only interested in the results applying to a certain small group, then that would qualify as a population. But 95% of the time in psychology research, in the social and behavioral sciences, we're using samples of people or samples of non-human animals in order to address questions. Okay, the second one, true or false? When samples differ from the population, there is a systematic difference between groups. Okay, think back to the visual we just went through. We had the two different samples. One group read the physical textbook, the other group read the online textbook. There was a 4-point difference between their test scores on average. Does that mean that there's a systematic difference between groups? Answer here is false. Remember that group differences can also be produced by sampling error, the natural discrepancy that exists between the population parameters and the actual sample statistics. The entire role of inferential statistics is to rule out that the difference is due to sampling error and hopefully give us support for our hypothesis. Okay, put more formally, sampling error due to random influences may also produce group differences. We call these group differences unsystematic because they're not predictable and they're not really organized. They're kind of chaotic and unpredictable. Okay, so that is going to leave us at the first half of chapter 1. So what I'm going to do is I'm going to stop this video here, and you will see another video posted shortly covering the second half of the chapter. Okay, so make sure that you read up to this point in the chapter and watch this lecture video before moving on to the second part. That's basically the way I suggest doing this. Make sure you have these concepts down, and if you're good on that, go ahead and move on to the second lecture video for chapter 1, where I'm going to be introducing some basic data structures, research methods, and basically study setups that we see in the social and behavioral sciences, different ways of organizing data. Okay, so I will see you in the next video. Thanks.